Hey everyone, it's Craig Maynard, for Senior Mentor and Control System Advisor for FRC West. There we go. Now we're set. I wanted to talk to you a little bit about the Roborio's digital input outputs we have along the side here. Now, very often people like to bring signals into this thing, things like limit switches or pressure switches or digital discrete sensors. A discrete sensor is one that's either 1 or 0. Or output things to lamps, output things to relays, perhaps to turn things on or off, output things to LEDs or lamps or sound effects, buzzers and things. Whatever you need to do. Digital I/O is really handy, and maybe not implemented as easily as one would think it is. It's not a very difficult thing to do. I just wanted to go through how you would set this up in LabVIEW. And to do that, we're going to make a very simple little circuit that's going to have 2 inputs into an AND gate and 1 output from that AND gate. So we can demonstrate the AND gate. I got a little breadboard here to make the connections with, a little LED and a 470 ohm resistor here. You're going to need have a couple of cables too. Some of these 3-way cables, so you can make the connection from here to the breadboard. We'll need a couple of those, and we'll need some wires as well. So you can pull those things together and get your Roborio ready. Let's see if we can make this thing work. So here we are in LabVIEW. We're going to start up LabVIEW with a brand new robot project. So we're going to do an FRC Roborio project. And we're going to call it AND gate, for lack of a better word. And I'm going to give it a team number here. Now the team number I put into my Roborio was team 1111. And arcade drive, it really doesn't matter what kind of drive we choose. And then we'll just finish that up and we'll let the thing configure itself. So here we are, ready to go with SolidWorks. And we can see there's our team codes. And we can put our code anywhere we like to. I can put it into this test.vi, which would be good. I'm going to stick it in the teleop VI. It seems like just as good a place as any for us to put it in. So we're going to open up this virtual instrument here. And there's our teleop. And in the teleop, we're going to take this and we're going to open up a block diagram. I'll just close those for now. We'll reopen those in a minute. And here's the program window, the block diagram window that shows our program. And we're going to just move off to a little space here that we can create our own add-on. We'll just use this little spot down here in the corner. Now, we're going to make a little AND gate circuit. So I'm going to right-click on here, and we're going to choose Boolean. And I'll pin this to the screen. We're going to just choose an AND gate. We're going to put an AND gate right here in our little empty space. Now, don't need that anymore. Now, if we go to the front panel and right-click on it, we want to put a couple switches on there. So let's go to Boolean, and let's add a couple of toggle switches. 1 toggle switch there, and I'll right-click on it, go to Boolean, I'll pin that down since we have a couple things to grab. I'll put another toggle switch below that one, and we'll put a round LED, which will serve as our output LED. Let's just move that over to the right a little bit. And I'm going to put a square LED right here, and I'll put a square LED right here, and those will reflect the state of those 2 Boolean inputs. Okay, good. So now we're going to go back to our program. So I'm going to set this aside. We don't need that. We're going to go back to our program here, and we're going to set some inputs up on this thing right here. So since we added these switches over on the control panel, you see they've actually showed up over here too. So let's just put them down. And we'll take these 2 Boolean switches here, and the Boolean 3 is our output, so we're going to stick it right here, and we will connect it. And we will hook up our AND gate, as you can see. Just like that. Thing of beauty. And now we have our 2 gates. Now let's put those indicator lamps up so we can monitor the condition. So it's called Boolean 4. We'll attach that to the first toggle, and we'll attach Boolean 5 to the second toggle, just like that. And Boolean 3 is already connected. So already we have a basic circuit which we could actually experiment with to make sure it's working. Let's try that. Let's run continuously here. Okay, now it's deploying. It could take a second for it to deploy the first time through. And we'll just give it a minute to chug through its process. It has to save it, and we save it, and we close that up, and now we should be running. So if I was to turn this Boolean switch on, that's high. Turn that one on, that's high, and if both of them are high, the output goes high, just like the AND gate would assume. So any one of them high doesn't do it. They both have to be high. So this is great. This is our AND gate. Now, we want to take this AND gate, though, and we want to take, I'm going to just take one of these inputs, and I'm going to tie it to one of my digital inputs on my Roborio, and I'm going to use another DIO as an output we can send to the lamp. So let's see how we would do something like that. So we'll just slide over here. Now to do that, we're going to need to have some more VIs. So I'm going to have to turn this off. Good. And now we're going to select down here. Now the DIs we're going to get are from the WPI programming library. You go to IO, and you go to the, not PWM, no, not PWM. We want to go one more time. The WPI robots library, IO, digital input, and we'll just pin that down. So we have some digital input we have to worry about. And then let's, since we're here anyways, let's go to WPI, input output, and we'll choose digital output. And I'll just put that window over here too, so we can quickly have access to it. Okay, digital inputs. Well, the first thing we have to do is we have to open up the device. It's every program has to have a program that actually receives data in and enables basically a device driver. So we're going to open up our input device by clicking DIN open, and we'll just plunk that right there. And we won't worry about these ones right now. And then we're going to do a get value. The get value is going to be the VI that actually gets the value and puts it in. Now the digital input, for the digital input, it has to know exactly which digital input output to choose. And as you recall over here, we've got 10 inputs. DIO 0 through 9. So we can choose any one of them. Let's choose 0 as our input. So we're going to go back over here. We'll right click on that, and we're going to create a constant. And the constant over here gives us all of the DIOs for 0 to 9, as well as the MXP 0 through 15. So there's a whole bunch more we could have chose. Those are all the MXP ones are all right along here. So if you want to use this for input output, feel free. All right, so we're going to choose DI0 as our input. Now this is connected to our DIN set, digital input, and then we can put the error string to the error input of the DIO. Now this DIO has got, the value is the middle connection. There's 3 connections on the output here, and if you want to know how this works anytime, don't forget you can always right click on it and click on help. And in a moment, help will come up with a screen that shows you all about that particular chip and what these input and outputs are and the kind of signals they are. Okay, so we can see here it's this middle one here that says value. I'm going to click on it, and I'm going to create a line that goes down to this Boolean switch. Now I don't want to have a switch and this output fighting for the same thing, so I'll delete my switch now, and you see it got deleted from my control panel, and I'm going to just use this as my input. Okay, now let's look at an output. How do we send an output out of our DIO? Well, the digital outputs are down here. We'll open up the device with that box, and we're going to choose digital DIO out set. Okay. So again, with this DIO out open, we're going to choose the input, and we're going to add a constant on there. And we can't choose the same digital input that we used for the input, so we'll choose DIO2 as the output. So DIO digital IO2 is going to be my output. And again, you just string these across from here to here. All right, so the signal and the error is sent over. And the output, or what you want to set it to, will be determined by this third input right here. So if you look here, there's a middle input called value. That's an input, and it wants to know, what are we going to do with it? Are we going to make it true or false? So we're going to connect it to the output of our AND gate. Connect it to the output of the AND gate, so the output of the AND gate is going to control this. Okay, this is good. So now the next thing we ought to do is go back to our Roborio and just wire up the circuit so we can see what's going on. So here we are. So I've got a couple of these 3-pin leads. We can see white for signal, red for power, and black for ground. So we're going to put that into the input, which is DI0, with white being on the signal line. Okay, and I'm going to plug the other end into my into my breadboard. You can see right there. Now, I'm going to need a couple leads. So the input, you can see right here, the input normally floats high. There's a 40,000 ohm pull-up resistor on there, so it's normally high. So I'm going to take it and I'm going to pass it through this push button right here, and out of the push button on the other side, I'm going to put it into ground. So hopefully, whenever I press this button, this input is going to be tied to ground and go low. Okay, and that'll be my input. Okay, for the output, we need another 3-pin cable like this one right here. And we're going to plug it into, I believe I said DIO2. So there's DIO2. And we'll plug that into our little circuit board as well. Plug it in over here. There we go. So the output pin is on the left side. And let's put it through, we could put it through an LED to ground, but I think the best thing to do would be to put it through a resistor. So we're going to put the LED through a resistor. To ground, and the ground is over on the 3rd pin here. There we go. And there we go. Now I've got the short lead going toward ground, so I believe the short lead of the LED, which I believe would be the anode, the negative side. And I'm just having a little bit of an issue getting the wire in there. That's right, I didn't give myself a good hole. There we go. So now, there we go. We have the power, the signal out going through the LED, through the resistor to ground. So whenever that's high, hopefully our LED is going to come on. All right, so let's go back to our program. Okay, I'm going to select Run Continuously. It's going to ask if I want to save it, and I'm going to say yes. And then it's going to deploy, as it's doing right now. And in a moment, it should be done. So you can see it's running right now. And I don't know if you can do it, but I'm just going to press this push button on here. So as I push it, Made a liar out of me. It was working a second ago. Oh, I'm pushing the wrong button. There's two buttons there. So as I push it, you see the Boolean 4 is turning on and off. And as Boolean 4 turns on and off, it makes the logic gate, the AND gate, fail. So it goes off. And of course, if I make the other input of the AND gate low, and then I press the signal, nothing happens, of course, right? Because 1 and 0 is 0, and 0 and 0 is 0. So yeah, so this works just great. So here I have made a very, very simple circuit that uses the digital input of the Roborio and a digital output of a couple pins down on the Roborio to make a real cool little working circuit that you can put into your robot and make it do all kinds of powerful things. So let me know how this video works for you, and please give me some kind of feedback about what you might have done with these ideas. All right, I'm going to go experiment with some more things, and I'll get it online for you. Thanks very much. Bye-bye.